The title of this talk is When Sounds Right Isn't Is Right. And I kind of struggled with that for a little bit, but if you've played around with large language models, you may have encountered this. So this is not necessarily unknown behavior. We've seen output that's really well formatted, the information reads really well, it's very fluent, and then sometimes it's just wrong. And you go back, and sometimes the model will double down on you I'm really sorry, I'm gonna give you a new response. And the new response is very close to the last response. So I'm gonna talk to you today over the next 30 minutes or so about large language model evaluation. Because one of the things I hear quite often from people is, these models are improving at exponential rates. And when I say, how do you know? They'll say, well, based on my experience. I've worked for an analytics company for almost 30 years. I can tell you that that N of 1 isn't statistically significant. So we have to look at the much bigger picture. So understanding how LLMs are behaving. What? Oh, nobody can hear me? Oh, oh, you're fine. Or I'll stand over here. Okay. It's fine. Is that better? Can you hear me? Awesome. Cool. No, you're fine. So this is a problem. LLM evaluation is a problem that is a lot harder than it looks for a variety of different reasons. First, the core problem is language models are really good at producing text that does sound right. And it's a bit of a fluency trap. They don't hedge, they don't back down, they don't second guess. They just present information in a way that is incredibly confident, grammatically correct, fluent, and could be wrong. I like to go back to this paper that probably nobody in the room has ever heard of. It's a paper from 1960 on the present status of automatic translation of language. The reason I like this is because the guy who wrote it, Yoshua Bar Hillel, was a linguist and a philosopher in the 1960s when the big AI problem was machine translation. So he wanted to understand what the status of automatic translation of language was in his paper in 1960. And a lot of people will say, did we even have computers in 1960? How much technology did we really have? But there were a lot of initiatives happening. There was the Georgetown IBM experiment in which Georgetown University and IBM collaborated to do machine translation of Russian sentences to English, which turned out to be a bit of a marketing thing. It was very well marketed. There were all these news articles about the robot brain and the remarkable work that this model did. It was a rules-based model that never would have generalized beyond those 50 sentences. But this guy was very interested in the idea of automatic language translation. And in his paper, he says something to the effect of, you can have fully automated, high-quality machine translation that reads well, is grammatically correct, and is absolutely fluent and 100% wrong. This was a guy in 1960. And when I read this a couple of years ago, I thought, this guy's talking about the same thing that we're talking about today. And what I've learned over time is most of what we're doing in AI has already been done multiple times. Now we're doing it at scale. So I first thought, is this guy a time traveler? But no, he just understood the landscape. And he understood that fluency doesn't necessarily mean accuracy. And that can be really problematic. So we end up in this situation of, it sounds right, but it's wrong. And in some cases it sounds right and it is right, and that's okay. But we don't really have a lot of truly empirical ways to understand what it means to be right in the terms of large language model output. So what's at stake? We can look at the news on any given day and realize that there are a lot of stories about generative AI and large language models gone wrong. From the lawyers that make up case law and get called out on it, and it costs a lot of money. Air Canada, their chatbot made up a refund policy and they had to abide by it. These are things that happen. Also, my favorite aspect is the sycophantic nature of the large language models, where you interact with them, they want to tell you how smart you are all the time. Every idea I have is absolutely brilliant. And I'm constantly blown away by that, because I sometimes look at these ideas and I think, it's pretty stupid. But my ChatGPT is perfectly happy to tell me how brilliant I am and how great an idea this is, and I'm really onto something. And I think, oof, I don't know if I like what's happening here. I will also say, in the scheme of AI, sometimes I come across as a bit of an AI doomer or an AI villain, and a lot of it is because I understand how these models work, and I want people to be more critical of the outputs, and especially if you're rolling them out in business. It's really important because there's a lot at stake. You know, nobody wants to be a headline, so let's avoid being a headline. Which brings us to the ways that large language models are evaluated today. It is a bit of a hodgepodge approach. Most of what happens, from the people that are telling me all the time that the models are improving at exponential rates, is human evaluation, where we're just kind of gauging based on our own experiences. And I have a lot of good experiences with my bots, but I also end up with a lot of information that is repetitive, that is too long, and I really love asking my bot to distill things down to 5 sentences, and then it gives me 7 or 8. And I think, okay, how about 3 sentences? And then it gives me 5. So, you know, there's still some challenges there. There are academic benchmarks. We have reference-based benchmarks. You may hear about terms like blue scores and rouge scores. And then there's LLM as a judge, which is my personal favorite, and that's the one that I'm going to be less than enthusiastic about. I feel like chaining together non-deterministic methods is not sound science. So when you do LLM as a judge, you're basically throwing caution to the wind. You get a set of metrics, and then if you make some changes to the data that you're feeding into the model, or you make some changes in the styles of prompting, and you run that evaluation again, the model may give you new evaluation metrics, but you don't know if the model is just making them up, or is it really changing the benchmarks based on what you've done to the data. There's no way to really peel it back and know. In no other field of machine learning would we do this. And in no other field of machine learning would we put evaluation as this afterthought. So there are a lot of things that people are doing with large language models that we would never do in any other field. But because it's language, and language is very accessible, it feels like, you know, it's a little bit of a softer side of analytics. It's not, because language has power, and we need to recognize that. So standard benchmarks have a tendency to fall short, and all the benchmark really does is tell you about the benchmark. Benchmarks can be incredibly seductive. High scores feel like you have some proof that things are working appropriately, but there's a pretty big problem with that. Top-tier models approach the upper bounds, as your top-tier models approach the upper bounds of your benchmarks, statistics like MMLU or human eval, those tests become less useful for distinguishing actual progress. The model's published benchmark score can predict production performance only when 3 conditions hold. The benchmark test tasks, that's hard to say, that's a language problem. The benchmark test's tasks, similar to your use case, the test is clean of the, and not contaminated with aspects that you're working with in your test cases, and that the benchmark hasn't saturated to the point where the scores differences are statistically meaningless. So you have to consider those 3 things. The fact that you have to test things that are similar to what you're trying to do in production, you have to make sure your training data is clean and not poisoned, and you have to make sure that you haven't gotten to the point where the statistical differences are meaningless. And that sometimes doesn't happen when you use benchmarks. So in all 3 conditions, they actually fail quite often. Data becomes contaminated rather easily. Models that score like a really high percentage, like 92% on something like MMLU, could still hallucinate on domain-specific terminology. So the benchmark tells you mostly about benchmarks and not really much about how your system is operating. And that's a really important thing to understand. Benchmarks are good at telling you about the benchmark. Good is not a universal concept. The deeper issue is that good is not, it's not universal. Generic benchmarks don't answer the questions that your organization actually needs to have answered. Is the model doing better than the last version of the model? Is it doing what my users are actually needing or what we're trying to set up our use cases to address? What counts as a correct answer in financial risk summary is going to be completely different from what counts as correct in a customer support chatbot or a clinical application. So the application matters. Standard metrics measure against generic outputs, and that's just a generic standard. So you can't have a one-size-fits-all approach to any of what we're talking about when it comes to evaluation. Your users aren't generic. They're not going to ask generic questions. Your domain's not generic. You can't apply an out-of-the-box frontier model in your business and expect good performance. The definition of quality has to be very specific. Also because evaluation is not just a quality question, it's a governance question. So when we start talking about actually gauging how well these models are performing, that feeds into governance strategies. And that's something that we have to really focus on. And it's really acute in the work that we do at SAS. You know, a lot of our customers are in regulated industries. We've got our financial services, healthcare, government, insurance. So evaluation can't just be a quality question. It has to feed into the overall governance movement. In these types of environments, hallucinations and bias aren't just model quality issues. They're systematic enterprise risks that require coordinated detection pipelines, formal evaluation metrics, and governance-aligned mitigation strategies. Without those, you can be one of the headlines that we looked at earlier. In our regulated sectors, misrepresentations from AI can trigger regulatory fines. Nobody wants to do that. Legal information alone shows that a 6.4 hallucination rate compared to just 0.8% for general knowledge questions is like the norm. So there's a vast difference between the information that we get when we start focusing on domain-related topics. Our customers need LLM outputs that aren't just fluent, because we've recognized that fluency doesn't necessarily mean accuracy, but you have to have metrics that are auditable, reproducible, and defensible. So when the regulators come calling, you can say, this is how I got from point A to point B. This is why we're making the decisions that we're making. And that's a completely different bar than just a leaderboard of performance. And there are tons of leaderboards out there that mark the so-called performance of some of these models. But it's these challenges that drove our NLP R&D team to try to look at things a little bit differently. And that brings me to what we're building and why we're moving down this path. So at the heart of everything that you do in an LLM, it's just text. You know, at SAS, we've been analyzing text for decades. I've been doing NLP for 25 years. So it's in the core fabric of everything that we do. You know, I've gotten to the luxury of seeing the market move from standard rules-based systems that were very deterministic but often didn't generalize as well as we would like them to statistical models, to machine learning and deep learning, all the way through to the transformer that was introduced in 2017 in the Attention is All You Need paper. So I've gotten to see the entire evolution of these models, and I've gotten to see the fact that in this realm, there aren't enough NLP experts, and that's why so many problems are presenting themselves. If you don't understand the tools that you have at your disposal, it can become really difficult to understand how to manage text inputs and text outputs. And it's not just about feeding them into more non-deterministic models. So before I get into the specific metrics, I want to share the principles that actually shape the approach that we decided to take. They are that evaluation needs to be task-grounded. Metrics have to connect directly to the task the model's performing. And I'll explain a little bit more about this in just a few minutes. But it's in this same realm that causes me a little bit of heartburn, because I speak to people all the time about what types of tasks they're trying to do with unstructured data. And very often they come to me and they'll say, we're going to use a GPT model, which is a generative text model, to do classification or summarization or machine translation. And I think that is just one model And it can be used as a general purpose model, but there may actually be better approaches for the type of task you're trying to perform. And the conversation that I've had a lot this week has been, we want to use a GPT model to do sentiment analysis. Sentiment is such an old school classification kind of problem. We've been doing it for a very long time. And I can tell you that a GPT model could work, but it's not the best tool. If somebody comes to me and says, I want to do classification, I want to do sentiment, I would point them to a BERT model, bidirectional encoder representations from transformers. It's part of the original transformer model that was introduced in the Attention is All You Need paper. It's the opposite side of the GPT side, because it's better suited for the task you're trying to work with. I feel like everything that we do in all of the analytics we perform should be grounded in some sort of a task. And we shouldn't just try to do everything as general purpose when there are better techniques available to you. The metrics need to be auditable. Every score needs to be traceable and explainable. And at the end of the day, everything that we do, especially in the realm of evaluation, needs to be owned. There has to be accountability. Metrics have to be maintained just like production code is. They can't just be this thing that you set and forget. You can't just do it once and then think that everything's going to be fine. Because if we've learned nothing in the realm of machine learning, it's that models degrade over time. Our results change over time. And we have to stay on top of the way our models are performing so we can guarantee the best performance for our organization. So the point is, we didn't start by asking what metrics exist. We started looking for what does failure look like for our customers? And what types of information do they need to move the needle to make sure that they're going to get the performance that they need out of these models that everybody wants to use? So we have a collection of custom metrics that we've started with. These are not production yet, but they're coming. We're planning to incorporate them into Model Manager and probably a couple of other things. So I've got a lot of ideas about things that I want to do with my NLP portfolio. The first one, and you'll see metrics up there that I've mentioned, blue, rouge, those are legitimate metrics. They're benchmarks. They're words that people throw out all the time when we talk about evaluating LLMs. Semantic similarity is going to evaluate how closely the model's response aligns with a reference or gold standard answer by measuring its semantic similarity, which brings us to gold standards. If you're going to implement a large language model, first you should have a narrowly defined, well-scoped use case. Because anytime we engage with modeling, you should always have a well-defined, narrowly scoped use case. And as a part of that, you should have some level of idea about what your customers are going to ask and the types of answers they should expect when they ask those questions. So I always recommend that you do some testing first. And you should develop a gold standard list of prompts and responses. That does a number of things for you. First of all, it sets the tone for the type of application that you're building and you're going to roll out to your customers, whether they're internal or external. What it also sometimes shows is once you roll things into production, you may find that your users are using that technology in ways you weren't actually expecting. But if you have a record of what your expectations were, you can gauge that against what your users are actually doing, and then you have the ability to more effectively pivot. So we're always going to be looking to compare what we're doing with a reference gold standard. This technique, the semantic similarity, uses sentence embeddings to represent both the generated and reference responses. So we always go back to the embedding layer, where we're converting everything that we do in language into numbers that we can then compare against. So the gold standard in similarity analysis in natural language processing is cosine similarity. And you can't do that if you don't have the numbers. And if it's been a while since you've thought about words like cosine, and you have to dust off your geometry brain, and we're just talking about the distance in an angle. So for those of you that don't know much about how NLP shakes out, see, I can't even do words, I'm almost as bad as a bot. The first thing that we do in NLP is we convert words to numbers, and we look at those words and assign the numbers based on the neighborhoods in which the words live. So if you have an ambiguous word like plant, some of you may not be thinking about all the ambiguous ways you can use the word plant, but plant can be a noun, it can be a verb, it can be an organic life form like a tomato plant. It can also be a place where you manufacture things. And chances are, if you have a bunch of information about organic life, you may not have as much information about manufacturing. So there's this old adage, you will know a word's meaning by the company that it keeps. So we embed our data, we create numbers that are hyperdimensional. The hyperdimensional nature basically says, I know if I see the word plant near things that look like tomato or rose or something like that, that's one sense of the word. If I see the word plant surrounded by manufacturing or emissions or something like that, I might be talking about something different. And making this number multidimensional helps us contain the information about the word's context. So there's a lot of really cool math that goes on behind the scenes that I won't bore you with today. But it's important to understand that as a baseline. So when we look at words like tomato and plant, they'll have a really close cosine similarity in that context. If I see plant and manufacturing, they'll have a different level of similarity. But there's a lot that has to go in because language is hard. I teach computational linguistics at Duke University on the side, and as a part of that, I have an entire lecture on why NLP is hard. And a lot of it has to do with the fact that language has a tendency to be very ambiguous. So we have to be intentional with how we analyze it. And especially when we start talking about analyzing text that's coming in and out of large language models. So I wanted to back up and talk about what an embedding was since I threw that out there. Our similarity score overall, like I mentioned, is done using cosine similarity between all of the embeddings, and that gives us an actual quantitative assessment of alignment between the model's output and the expected answer. And the accuracy score is going to range from 0 to 1. So we give it, it's not a binary necessarily, but it is a range. Our term similarity, which falls in the same sort of bucket, operates similarly. With the semantic similarity, we're looking at sentence embeddings. Term similarity is going to show us how closely the model's response aligns with the gold standard, just like the semantic. But in this case, we're going to be looking at lexical overlap rather than the deeper semantic meanings. So this is where we use a really old school technique called the n-gram. Has anybody ever heard of an n-gram? So n-grams are cool because n-grams were the very first language model ever developed. Anybody have any guesses on when the first language model was introduced? 60s. Close. He said 60s. It was actually in the 40s. In the 1940s, a man named Claude Shannon, like Anthropic Claude. Claude Shannon's my favorite innovator of all time, so I use every opportunity I can to share the word of Claude Shannon. But the Anthropic's model Claude was actually named after Claude Shannon. But in the 1940s, Claude Shannon worked for Bell Labs, which was telephone. And his paper, A Mathematical Theory of Communication, was written because he wanted to understand what happened when you had a noisy channel that you're trying to move information across. So if the signal drops, how would you fill in the blanks? So if somebody was talking to their friend about pizza and they said, I really like my pizza with cheese and the signal drops, the first word most people would fill in the blank there would be pepperoni. So the n-gram is a model that says if I have one word, I can predict the next word. If I have two words before the word I'm trying to predict, I have a little bit more context, I can predict the next word. So the higher the order of the n-gram, the easier it is to predict the outcome. The challenge with n-grams is the fact that they don't generalize very well because it just knows information about the words that came before it and not any of the longer term dependencies that exist in language. So it was a bit of a problematic approach to language modeling, but his main goal wasn't really generative text. It was just trying to figure out what happens when you have a noisy channel and you drop. But we are able to use those types of techniques that are still widely used in NLP decades later to help us with this idea of assessing semantic term similarity, not the semantic side. So it does use Ngram-based methods, and those Ngram-based methods are our Blue and Rouge scores. So Blue scores, and the reason my feathers get ruffled when people start throwing out Blue and Rouge scores with generative text, is Blue scores were originally developed to assess the results of machine translation, which kind of looks a little bit like novel text generation, but not really. So it kind of takes you back to, you can use a GPT model to do everything if you want to, but it's not really always the best model for the task. Same thing with Blue scores. You can throw Blue scores at generative text, but it may not really be the best fit because you're not doing machine translation. Rouge scores were developed to assess the quality of text summarization. So if you're using a GPT model to do summarization, Rouge is a great metric for it. But it's not a great general metric across the board for all text generation. And the same thing goes with scores like Meteor. So they're going to compare words and phrases, will reward exact or partial matches within word sequences, and we're emphasizing precision and recall and literal text overlap. So that's why the Ngram works fairly well, because we're just looking at smaller aspects of the string, and we're looking for literal overlap. So if it matches, great. If it doesn't, it doesn't give you a good score. So the score is going to give us a quantitative measure of alignment, and that's also going to range between 0 and 1. So those are kind of table stakes in the scheme of things. Next on the list is consistency. And this is one of my favorites, because you can ask a large language model the same question 7 times and get 7 different responses. So if I'm rolling out a bot to my internal or external customers, and understanding that often when we do this, they're sort of helper bots, and people in our organization may ask the same question multiple times. So you don't want people in different departments getting different answers for the same question, unless there's departmental data we have to take into consideration, but we're not going that far. We want to make sure that everybody has a very similar experience. I can tell you this is a problem because the first assignment that I give in my class at Duke is ask ChatGPT or a bot of your choice to generate Python code to do anything you want, don't care what it is, run that code, and then ask the bot to revise it 3 times. Don't care what you're asking for revisions on, and then tell me how it goes. In a class this semester of 75, I had more than a couple of students who did the same thing. And this happens every semester. I started doing this in spring of 2023, so right when ChatGPT came out. In those days, it was significantly worse than it is today, but for some students, it's still as bad as it was in 2023. So I can have students that do very much the same thing, asking the question of the same bot, sometimes even just the paid version of ChatGPT, because they have to tell me what they're using. So I'm able to gauge very similar prompt, same model. One student will come back and say, it ran flawlessly, everything I asked for was perfect, the code was great. The next student will come back and say, it would have been easier if I'd just written it myself, because I had problems every step of the way. And sometimes the problems were very basic things. There's no consistency there. So we have to understand how consistently our model's responding. And that's a measure that we take very seriously. So using our NLP chops, comparing against gold standards, we can help you understand how consistently your model's responding to the same or similar prompts. And it doesn't have to be verbatim same, because we've already talked about what it means to be similar. And NLP, we're great at doing similarity. So we can tell you based on some fuzziness in a prompt, how consistently the model's responding. And if it's just minor nuance, that's fine. But if you're getting responses that are way out in left field, that's something you have to take into consideration. You have to figure out a way to mitigate or manage. Faithfulness establishes how aligned and consistent the model's response is with the input. In this case, we're looking at hallucination evaluation models, and that's going to assess whether the response is going to introduce unsupported or inaccurate information. It'll also be within a range of 0 to 1, and the higher value indicates that there's a stronger factual alignment with the input. So we want to make sure that the responses that we're getting to the prompt match up with what the prompt is actually asking. So if you've used a bot in the past 12 months or so, you may see that sometimes the response starts off fairly faithful to the prompt and then starts to level off. And then the more you go down the path, the worse the response gets. And the more you can continue the conversation, it gets even worse. So sometimes the performance degrades over time, and these are things we need to understand. We need to understand how faithfully our model is responding to the prompts so we can do our best to figure out a way to mitigate that. And then the last one is actually my absolute favorite, which is comprehensiveness. In the early days of large language models, people were much more intentional about their prompts than they are now. People have gotten so comfortable with the idea of large language models that I was joking with my moderator earlier about our husbands. Mine loves his co-pilot. I mean, he's got an unhealthy relationship with his co-pilot. It's like his buddy, and he asks the thing all sorts of stuff. And his prompts are very conversational. So it's no longer just simple question-answer kind of things. It's like a bunch of supporting information, and then some more information, and then finally gets to the point of what he's asking, and then he gets a response. He's using it for fun, so it doesn't really matter if the model goes off the rails, and sometimes he very much enjoys it when it does. So comprehensiveness, how do we gauge the quality of responses to long prompts? This also becomes a particular interest for people that are deploying bots that have very long system prompts. So before Innovate, about a month ago, there's a team downstairs in the hub that has built an application that talks about the history of SAS by the decade. And they came to me and they said, we're going to use an LLM behind the scenes, and we want people to find really cool information that was going on in the decades that SAS was in business. So there's a bunch of stuff that we don't want it to talk about because we don't want it to be a bummer. And we introduced a bunch of do not logic in the middle of the prompt, in the system prompt, that says things like, do not mention in the 1970s Watergate or the Vietnam War. In the 1980s, don't mention the fall of fall of the Berlin Wall. In the 2000s, don't mention COVID. The model hadn't actually been doing any of that until they introduced the do not logic. And they put this, it was about a 120-line system prompt. They introduced the do not logic in the middle of it, and the model latched on to that do not logic and started spitting those answers out consistently, which was not what they were expecting. So they called me and they said, Mary, we don't know why it's doing this. We told it not to. It hadn't been doing it before, and now it's doing it all the time. So how do we fix this? And I said, oh, you've got a prompt comprehensiveness problem. Like, first of all, your prompt is probably too long. But second of all, based on all the work that we've done with how a model responds to prompts, we understand that models are very much like humans in this regard, not nearing human capability. But they remember the first thing you say and the last thing you say, and the middle gets muddy. And depending on the model, sometimes it's muddier than others. So this is a result from a 5-part prompt. Pretend you're a famous rock star who's giving an interview, answer the reporter's questions, making up details about your career, use full sentences in a conversational tone. You can see that they did both models did really well with the first part. They both decline a little bit with the second part. They go down, Claude specifically, falls apart a little bit on the third part, to answer the questions. And then they start picking back up at the end. So, if you're developing huge prompts, be mindful that you put the stuff that you really care about near the beginning or near the end. So they did. They modified the system prompt, but still ran into a problem because by then the model had already latched onto these terms and it really liked them. So they had to clear it all out and start again so the model was no longer contaminated. So these are some things we have to think about. Prompts matter, size of prompts matter, and the more we do with system prompts, that really matters. So we have to figure out a way to gauge how comprehensively the model's responding to those different pieces and parts. And this, like I said, this is my favorite aspect because prompts have gotten very long, even in users. I mean, like I said, I look at what my husband does with his Copilot, and I'm like, dude, you just fed it like a novel. You were really expecting to get fantastic results from that? And he was like, no, not really. I just wanted to see what happened. Okay. So I mentioned that these metrics will ultimately end up in Model Manager in VIA. This is just a really difficult to read screenshot. It'll be better in the PDF document if you want to download that. But this is an indication of what the evaluation metrics will look like in a visual way. So instead of just giving you, a range of 0 to 1, we can start looking at how the model is tracking these metrics over time. So you can start seeing when the model starts to degrade. We're also working on agentic drift detection. So as you're using LLMs, we can monitor the drift over time and start seeing when the model's going to degrade by incorporating some of these metrics even in that aspect. So there's a lot of work we want to do continuing down this path, but these are our starting metrics. So what it means to you is we're not done. We have a lot more things that we want to accomplish. And some of those include things like relevance, like how closely, or how much does the model actually stay on topic? So if you have a banking bot, for example, and your user says, can you help me open a new account? The process was so smooth the last time. And the bot comes back and says, oh, I'm really glad to hear that the experience the last time was really great. Here are some really cool things we can do, blah, 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 blah. In a small chat box window, all of a sudden now you've got a paragraph. Nobody's going to read that. And that's a really expensive token cost. You want the model to just stay on point, maybe be a little friendly, but not overly, and stay on topic and answer the question. I just wish my bots would just answer the question and not give me the, master's thesis about what's happening. Factuality, are claims verifiable against trusted data sources or retrieved context? So actually gauging whether or not what the bot is putting out is correct, is factual. And then coherence. Are we going to maintain a logical flow as we go through, or does the languaging start to fall apart a little bit? And I've seen this in some models, Gemini, where it starts off okay and very fluent and readable, and then sometimes it just goes a little off the rails. So we need to be able to measure coherence, causal reasoning. Can we have a model that will infer, generalize, and handle things like counterfactual logic and do it successfully? Adversarial resistance, we have models right now that can be used for things like red teaming and adversarial testing, but taking that one step further, if you give these really long, noisy, ambiguous prompts, how resistant is the model to going off the rails on it? Is it able to see through the noise and actually answer the question? Because people are going to continue to be very verbose with their prompting. Uncertainty alignment, this is the one I've just started talking to my R&D teams about. And when I first mentioned it, they said, Mary, that sounds a little hand-wavy and woo-woo. But I want to get into a situation where I can have the model say, I'm only 40% confident that this answer is correct. We can do all kinds of cool things in NLP. So I was like, challenge is yours. So we're working on trying to figure out if there's a way to do uncertainty alignment. And there's been some research in this area. There are bits and pieces that sort of make sense, but I have confidence that my team will be able to pull something like this off. We also want to look at things like tone adjustment, making sure that the model is maintaining a tight, neutral tone, not being overly friendly or overly doom and gloom. Policy alignment, being able to cross-verify text against standards or policies, which also falls into the aspect of governance. And then putting all of this stuff into agentic workflows. You can't talk about anything LLM related these days without considering the impact from agentic systems. So this can be used as a part of agentic systems, since a lot of agents are rooted in LLMs. You want to know how your agents are behaving, and these are some of the ways that we can accomplish that. So the takeaway I'd ask you to carry out of this room is that evaluation is product work. It's not just like this sort of end of the game thing that you do. It's not a research exercise that you do once before you launch a product. Underlying models can be updated silently, and that can cause shifts in the behavior. And if you don't have continuous monitoring happening, you may not see it until it's too late. Metrics have to be owned by someone, which is the accountability side I was mentioning. They have to be maintained over time. Like I said, it's not just a set it and forget it kind of thing. I started all of this with the idea that sounding right and being right aren't the same thing. And I hope that I've helped make a case that, the gap between some of these things actually is measurable. And we can't always rely on the easy path to get us there. I mean, it's going to take our narrowly defined, well-scoped use case, our gold standard prompts and responses, so we have something to compare against. And for the record, I think LLM as a judge, and this is Mary Osborne, not SAS, I think LLM as a judge is a ludicrous way to evaluate large language model output. So if you take nothing else away from that, that's what I'd like to leave you with. Does anybody have any questions?
Thank you. I've seen some of your lectures before with us. I'm at AES. I've loved all your talks. They've been great. And I wanted to utilize some of the things that we tried out, because I'm not as great at this as you are. But we've been working with Copilot Studio a lot, because we have a lot of that stuff as well in our suite of tools. And I've tried to use it for OCR, finding certain documentation or certain things in a PDF. And I get not great results because it's not in the metadata. I learned about that too as well, because just because it's signed off in the document doesn't mean it's in the metadata, and that's been a fun thing too. And I've had accuracy issues. I'm not sure if that's the greatest way to go with that model, using a Copilot or a GPT type model to find stuff, if there's a better route to go.
To try to extract information from documents,
Yes.
there might be better ways to go.
I see.
Because with a use case like that, you would have to be very intentional about the types of information you're asking for. Sometimes it can look like named entity resolution, where you're just trying to extract people, places, things, organizations out of documents. And we have models in the NLP toolkit that do that, have been doing that for a very long time. But it is really easy to sort of default to Copilots because they're available. And most people haven't had the experience playing around with NLP tools, and NLP can be a little intimidating.
Sure.
So there are probably other techniques that you might have more success with. I'll be at the NLP booth when I'm talking about it, and I'd be happy to take a look at your use case and see what you have and recommend some things.
Awesome, because I felt like it's a little overkill for what I need.
Yeah, so, I mean, sometimes, like I said, people have been trying to extract information from documents forever. And sometimes we can get by with rules-based approaches that are deterministic, run really quickly, have very low overhead, and are explainable to people. So there might be something else in the toolbox that we can use.
Thank you.
You're welcome.
Hello, Mary. Thank you very much for your speech. It was really great. And I just wanted to ask you to talk about these metrics, right? But let's say in a production environment, how do you handle when the model is not actually responding? Do you have any type of fallback to go through once the modeling has responded? Or do you recreate the answer again with LLMs?
If the model doesn't respond?
Yeah, if the model doesn't actually respond the way it's meant to be, right?
Oh, yes. So, like course correction.
Yeah.
Something like that. So when we started looking at the do not logic in that long prompt I was talking about, I said, well, one way you can get around that, where the model is getting response that is bad, is we can insert a tiny little linguistic model before the response hits the user and look for those very specific patterns of things that you don't want and stop the model from responding that, reprompt, and bring it back until the model gets it right and gets something that passes the threshold. So it's almost like guardrailing. So guardrailing is one aspect or one way to handle responses that you really don't want to see in a model and you don't want your users to ever see. And the most common guardrails people talk about are things like toxicity and bias. There's some around PII, where you don't want the misbehaving until you can figure out why and try to refine tune or modify the way you're prompting. There's so many, it's such a huge black box. It can be really difficult to nail down why the behavior is the way it is. So sometimes the easiest path is to guardrail against it.
To add another layer, right, on top of it. Great, thank you.
You're welcome.
Can the same metrics you were showing us, can they be used for RAG systems as well? Like is it different though in the sense that you need to evaluate your retrieval piece and the LLM portion? Or is there benefit in evaluating those two separately or just in one system altogether?
I actually love RAG because there's so many moving pieces and parts. So you would use the evaluation metrics to gauge the output that the model presents. And there's still, even though you're grabbing from a vetted source, the model can still misconstrue that source. So you can still apply some of these metrics to the end of that. Where I like to get involved is, and an area that we're working on right now, is semantic chunking to help improve the matches that you get. Because chunking is such a dark art now, and it requires a significant amount of experimentation, and they're just, it's the number one challenge I hear from people implementing RAG is we don't know how to chunk the data. And we've gone through a bunch of different exercises, and we're not even sure what's working right anyway. So if we can let the data tell the story in the chunking aspect, and then be very mindful of the types of similarity analysis we're doing when the crossroad comes, when the embedded query hits the chunks. If we can be mindful of the technique that we're using to do that similarity analysis, we can improve things as well.
Okay.
When I first saw RAG, I thought, this is crazy, because this is basically just search, and we've been doing this for a long time. And what I see in a lot of RAG systems is best practices that we've applied to search for decades aren't being followed. So you can also look at things like, in addition to evaluation metrics, you can look at incorporating old school techniques like taxonomy to help better guide the model and the types of information it's returning back to the user. So I feel like in some cases with newer approaches, we need to kind of go back to basics and utilize things that are still in the old school NLP toolbox that can bring us some value.
Cool. Thank you very much.
You're welcome.
And we may have time for one more.
Yeah.
Anybody?
Yeah. Hi. Great presentation. I see lots of good metrics here. Just wondering, is some of the metrics have to be evaluated by human being? You know, you get that, you get a prompt, you get a result. Have to be somebody, human being, see if that result from the prompt really meets the, what the intention you meet.
You'll never get rid completely of human evaluators. I mean, humans are going to always have to be in some level of loop here because language is so uniquely human.
Mm-hmm.
And even with solid evaluation metrics, that can't be the only thing. So users will always be a good judge. Always is fairly strong because I've seen some that are not great judges. But users are important because they're the ones that are going to continue to use the application. And if the information that they're getting doesn't line up with what they're expecting, they may not know that it's a factuality problem or it's an alignment problem or a faithfulness problem, but they know that there's something wrong. And having that information and being able to provide that level of feedback, the feedback loop through reinforcement with human feedback, the thumbs up or thumbs down that you can do, that can be helpful. Because that can at least help inform the administrators of the model and the model itself that, yes, this was a good response or this was a bad response.
Mm-hmm. Yeah. Okay. Thank you.
You're welcome. And that's actually one of my favorite things that happens now with the bots, where they force you into the situation where you have to choose whether it's good or bad. And I really like when they pop up two different things, and I'm like, which one of these do you like best? And I think, well, I like the first part of this one and the second part of this one. So I don't have an answer for this. But they won't let me go forward until I choose one. So that's a challenge.
Thank you guys for coming, and
Thank you so much. I
Mary.
really appreciate your time.